Okay, so we've solved systems already by using graphing and by using substitution. And today we're going to use a different method, a method called elimination. So assignment number 3, and here are some examples. You can watch this video if you go to the PowerPoint in the Canvas assignment, just as a teaser to this first problem. So here's your riddle to solve. It says, I am thinking of two numbers. They have a sum of 37 and a difference of 7. What are they? And so we have to figure out what these two numbers are. And so we're going to start by writing an equation. If the two numbers have a sum of 37, then let's say that one number is x and the other number is y. If their sum is 37, that means when you add them together, you have to get 37. But then it also says their difference is 7. So if we assume that x is the bigger one and we subtract y, which would be the smaller one, that means their difference has to be 7. And so we have a system of equations that look like this. So we could graph both of these. We could use substitution, get either the x or the y by itself, or we could do this. I'm simply going to take these two equations and add them together. So for example, if I take the first equation, I have an x plus an x here. That's x plus x, that's 2x. Y plus a negative y. So when I add these together, y plus a negative y is nothing. Those two are eliminated. And over on this side, 37 plus 7, well, 37 plus 7 is 44. Well, now I have an equation that's 2x equals 44. I can find x really easily. If I just solve, or if I just divide both sides by 2, I'll get that x is 22. Now, that's half of my answer. I want to figure out what y is, but let's say I take the top equation here, and I'm going to replace this x with 22. So it's 22 plus whatever y is 37. So I want to get the y by itself. I'm going to subtract 22 from both sides. So when I do that, I'll have y equals 37 minus 22, which is 15. Let's just see if we did find these numbers. Do these two numbers have a sum of 37? Well, it does 22 plus 15 equal 37. Well, that does. And do they have a difference of 7? 22 minus 15, does that give me 7? And that also does. So my solution is, my two numbers are 22 and 15. And that's solving by elimination. We're just adding the two equations so that one of the variables is eliminated. Let's take a look and see how that works with a different problem to set up. It says that popcorn is 50 cents less than twice a Coke. However, the popcorn and 3 popcorns and 2 Cokes cost $10.50. How much is a popcorn and how much is a Coke? Well, I'm going to let X be popcorn and I'm going to let Y be Coke. And so it's going to look something like this. Popcorn is 50 cents less than twice a Coke. So we have popcorn. I'm going to call that X. That's 50 cents less than twice the cost of a Coke. And so that's going to equal, X is going to equal 50 cents less than twice the cost of a Coke. Well, here's twice the cost of a Coke. That's 2 Cokes, 2 times Y. But the X is 50 cents less than that, so minus 0.5. So there's one equation. And then if we look at this equation, it says if I bought 3 popcorns, so that's 3 X's, plus 2 Cokes, that's 2 Y's, it's going to cost me $10.50. Well, there's certainly this is certainly a good equation if I use substitution. I could just take the 2y minus 0.5 and substitute that in for x down here and solve this equation using substitution. But I could also use elimination here. Let's say I take this top equation and I get the x and the y together on the same side of the equation, just like I do have down here. In other words, I'm putting this in standard form. I'm going to subtract 2y from both sides, which means on the left-hand side, I'm going to have negative 2y plus my x. And that's going to equal negative 0.5. And all I did is subtract the 2y from both sides. Then I can rewrite the second equation. The second equation is 3x plus 2y. So I'm going to write it as, I'm going to put the 2y here and the 3x here, and that equals $10.50. I did it so that the y's line up, the x's line up, my equal signs line up, the number on the other side all line up with each other. Now if you watch this, if I add them together, the y's are actually going to be eliminated because this is negative 2y and a positive 2y. Those, when I add them together, I get nothing. But if I take 3x plus 3x, that gives me 4x. And a negative 0.5 and $10.50, well, that's $10.50 minus 50 cents. That's just 10. So then if I divide both sides by 4, x is 10 divided by 4, which is 2.5. Or in this case, $2.50. So that is how much a popcorn cost. So popcorn, which is x, is $2.50. That's the first part of the question, but we also want to figure out how much a Coke costs. Well, once I know what x is, then I could plug that into either one of my equations to figure out what y is. So let's say I use this second equation here. 3 times x, that would be 3 times 250, which is $7.50, plus 2y equals $10.50. So I'm going to get y by itself. I'm going to start by subtracting 750 from both sides. And if I do that, I'll have 2y equals 1050 minus 750. Well, that's just 3. And if I divide both sides by 2, y equals 3 divided by 2, which is 1.5, or in this case, $1.50. And so the cost of a Coke is $1.50. And we already have the cost of a popcorn is $2.50. So we can answer the question by using elimination. Let's take a look at this situation here. We have 4 hamburgers and 2 fries cost $24, while 3 hamburgers and 4 fries cost $23. So how much is a hamburger and how much is an order of fries? So I'm going to let the hamburgers be x. I'm going to let fries be y. So in the first example here, which is this one right here, if I buy 4 hamburgers, that's 4 x's, plus if I get 2 fries, that's 2 y's, it's going to cost me a total of $24. And in the second situation, if I get 3 hamburgers, that's 3 x's, and I get 4 fries, that's 4 y, it's going to cost me $23. So here's my system of equations. And this one's a little bit different because if I take 4x and 3x, it's not going to be eliminated. It's going to be 7x. If I take 2y and 4y, that's not going to be eliminated either. It's going to give me 6y. 2y and 4y is going to give me 6y. But here's what I can do. I'm going to take this equation right here and multiply it all by -2. And here's why. If I multiply it all by -2, instead of having a 4x, I'll have a -8x. Instead of having 2y, I'll have a -4y. And instead of having 24, I'll have a -48. But now if I take these two equations and add them together, one of the variables will be eliminated. I have a positive 4y and a negative 4y. So the reason I multiplied this top equation here by -2 is so that I would have two numbers that are opposites of each other, which I do with my y's. And now my y's are going to be eliminated. I have 3x minus 8x, well that's -5x, 4y and a -4y, those are eliminated, and then 23 and a -48, well that's a -25. And so now I have eliminated my y's, and I can solve this equation for x by dividing both sides by -5, and I will get that x is equal to positive 5. And so x was a hamburger. That means that a hamburger cost $5. So $5 for a hamburger. That's what x is. Well, then I want to figure out how much do an order of fries cost. Well, that's what y is. So I'm going to take one of my equations that I started with, which is this top equation, and it's 4 times x. Well, we know that x is now 5. So it's going to be 4 times 5 plus 2y equals 24. And so 4 times 5, that's 20, plus 2y equals 24. If I subtract 20 from both sides, then I'll have 2y equals 4. And if I divide by 2, then y is 2. So that means that y, which is the cost of an order of fries, is $2. So it's $5 for a hamburger and $2 for the order of fries. All right, let's take a look at these two situations here. The first one is pretty easy. I can just add these together right away and my y's are going to be eliminated. And so 2x plus 5x is 7x. 3y and a negative 3y is nothing. A negative 11 and a positive 25, well, that is 14. If I divide by 7, then I get x is equal to 2. But I'm not done yet. I have to figure out what y is. And so I'm going to use this top equation here. I have 2 times x. Well, that's 2 times 2, which is 4, plus 3 times whatever y is gives me negative 11. Well, if we subtract 4 from both sides, then we'll have 3y equals negative 15. And if I divide by 3, I'll get that y is negative 5. And so the solution for number 4 is the point to negative 5. And I could plug that into both equations, and if I plug it into the first equation, it should give me a negative 11. And if I plug a 2 in for x and a negative 5 in for y into the second equation, it should give me a positive 25. Let's try number 5. This one's a little bit more difficult because right now the x's aren't going to be eliminated, and neither are the y's. But what I can do is I can take this top equation here and multiply it times 2 so that I have a negative 2 and a positive 2y. So if I multiply this equation by 2, it's going to be 6x minus 2y equals negative 2. And then if I take these two equations here and add them together, 2x plus 6x is 8x. 2y and a negative 2y, they're eliminated. And 10 and a negative 2, well, that's positive 8, which means when I divide both sides by 8, x is 1. So then I'm going to take the top equation here, 3 times x, well, that's 3 times 1, which is 3, minus y equals negative 1. Well, if I subtract 3 from both sides, I'll get negative y equals negative 4, which means positive y has to be positive 4. And my solution is when x is 1 and y is 4. Let's do one more question. And so this question is a little bit more challenging than the others because I can't just, right now the x's aren't going to be eliminated and the y's are not going to be eliminated. And it's not like I can multiply something like 2 by something to make it negative 5 very easily. I can't multiply 3 by something to make it negative 4 very easily. But what I can do is this. Let's say I want to eliminate the x's. I can make this x here negative 10, and I can make this x here a positive 10. So what I'm going to do is multiply both of these equations by something. The first equation I'm going to multiply by a positive, let's multiply by negative 5. So if I multiply the first equation by a negative 5, 2 times negative 5 is negative 10x. 3 times negative 5 is negative 15y. And then 15 times negative 5 is negative 75. Then I'm going to take the second equation here and multiply it times positive 2. And so 5 times 2 is positive 10x, 4 times 2 is positive 8y, and 13 times 2 is positive 26. Now, when I add these together, my x's will be eliminated. So negative 10x and a positive 10x is nothing. Negative 15y and a positive 8y, well, that's negative 7y. And a negative 75 and a positive 26 is equal to a negative 49. So now I can figure out what y is. If I divide both sides by negative 7, y is going to be positive 7. But then I need to figure out what x is. So I'm going to go back. Let's use the second equation here. It's 5 times x plus 4 times y. Well, y is 7, and that equals 13. So I'll have 5x plus 28 equals 13. If I subtract 28 from both sides, I'll have 5x equals negative 28, or 13 minus 28 is negative 15. And if I divide both sides by 5, then x will equal negative 3. So my solution is negative 3 and positive 7. And that's how we solve systems using elimination. Good luck with this assignment, and we will see you tomorrow in class to go over questions.